Hello, this is Leroy Meadows, and welcome to this session where we are going to work on exercise 11-29 at the end of the chapter on decision making and relevant information. This is exercise 11-29, so let's go ahead and get started. The Denver Corporation manufactures filing cabinets in two operations, machining and finishing. It provides the following information, and then we're given this information here, and we're going to actually delve a little bit deeper into this here in just a moment. Each cabinet sells for $75 and has direct material costs of $35 incurred at the start of the machining operation. Denver has no other variable costs. Denver can sell whatever output it produces. The following requirements refer only to the preceding data. There is no connection between the requirements. So we're going to look at each one of these requirements, and we're going to look at that based on the data, and there's no connection between requirement 1, requirement 2, requirement 3, or so forth. So let's take a look here and just analyze this information before we jump in. Now we see there are two departments here, the machining and the finishing department. What is the capacity, the annual capacity between each department? We have 120,000 units that can be produced and have units go through the machining department, but we can only have 100,000 units enter the finishing department. So what are we looking at here? Well, the finishing department is what we would consider our bottleneck operations. The bottleneck is the department that can produce or output, have the capacity, the lowest annual capacity that can come out of there. And that can be annual, that can be monthly, that can be per shift, however we want to look at it. But the capacity-wise, the department with the least amount of capacity is going to be our bottleneck operation. So let's take a look here, and let's look at annual production. An annual production is only 100,000 units. And that makes sense because the finishing department can only deal with 100,000 units at capacity. So it makes sense that if that's our bottleneck, then our bottleneck is going to constrict our annual production to the amount of output that our bottleneck is. The finishing department is our bottleneck because it is the one that's slowing down production. So as far as we could make, if the finishing department could produce or output more like 120,000 units like the machining department would, then there would not be considered a bottleneck. But because it can produces less units on an annual basis because of capacity, that is going to be our bottleneck because that's where we're going to be slowed down at. And the bottleneck, whichever one has the lowest annual capacity, is also going to be that department that controls or limits production to whatever that bottleneck is. So it makes perfect sense that if this is our bottleneck here and it can only produce 100,000 units, our plant can only produce 100,000 units in the year. Fixed operating costs, not including direct materials, 600,000 in the machine department, 300,000 in the finishing department. So on a per unit basis, it's going to be $6 of fixed manufacturing cost per unit in the machine department, $3 per unit in the finishing department. And how do we get that? We take our fixed operating cost per unit and divide that by the number of units that we can actually produce. So let's take a look here. Let's go to requirement 1. Denver is considering using some modern jigs and tools in the finishing operation that would increase annual finishing output by 1,150 units. The annual cost of these jigs and tools is $35,000. And we're asked, should Denver acquire these tools? And we're asked to show our calculations. So let's go ahead and look up here in the upper left-hand corner for requirement 1. Now we know that the incremental cost of the jigs and tools we're told is going to be $35,000. Now that's our cost, so $35,000. But how much will that give us? How much will that provide? And let me just go ahead here and format these cells. Now, how much will that provide? Well, the increase in throughput margin, which is what we're looking at here because we're just taking our revenues minus our direct materials. We have no other variable costs, so we're just looking at throughput margin here. We could consider that contribution margin also, but since there are no other variable manufacturing costs, we can just mark this as throughput margin. What is throughput margin? Revenues minus our direct materials cost. So each cabinet sells for $75 and has direct material costs of $35. So what's my contribution or throughput margin per unit in this situation? Well, it's what? $75 minus $35 on a per unit basis is $40 per unit. Now, how much additional throughput margin will we incur if we make 1,150 units? So I'm going to take my throughput margin per unit times the 1,150 units additionally we're going to make. So that's going to generate an additional $46,000 of throughput margin. So what is my increase or decrease in operating income? Well, I'm going to have an increase of $11,000. And why is that? Because the increase in throughput margin is $11,000 more than the incremental cost of the jigs. So I can spend $35,000 for these jigs and tools, and that's going to generate an additional contribution or throughput margin of $46,000. So I come out ahead by $11,000 in operating income if I go ahead and buy these jigs to increase output. Now, let's take a look at requirement 2. The production manager of the machining department has submitted a proposal to do faster setups that will increase the annual capacity of the machining department by 9,000 units and would cost $20,000 per year. Should Denver implement the change? And we are asked to show our calculations. So let's take a look here and look at the machining department. We already have capacity for 120,000 units. Is this our bottleneck operation? No, it's not. So would adding capacity even make sense in this situation? No, because I can add all the capacity I want. Let's say I spend $20,000 and I spend $20,000 and I get another 9,000 units of capacity per year. So let's say that I do that and my annual capacity is $129,000 for machining. Is that going to make a difference on total output? No, it's not. What's going to happen is going to make the bottleneck even worse because that gap between what machining can do and what finishing can handle is going to be even greater. So does adding capacity to the machining department make sense here? No, it does not, because it already has enough capacity. It has more capacity than what we can produce right now. Now, if we were talking about the finishing department, then increasing 9,000 units at a cost of $20,000 per year, then we could look to see if that makes sense. However, because we're adding capacity in the bottleneck, and when we're adding capacity in the bottleneck department, then that's going to allow us to increase the output. So if this was the finishing department, I would say yes. Let's take a look, run the numbers, and do it. But we don't even need to run the numbers for the machining department. Why? Because that's not our bottleneck. We can add capacity, but it makes no sense to spend that extra money of $20,000 per year because it's not going to increase output any. Because I'm limited to 100,000 units of output because of the finishing department. Now let's look at requirement 3. An outside contractor offers to do the finishing operation for 10,000 units at $9 per unit, triple the $3 per unit that it costs. That it costs Denver to do the finishing in-house. Should Denver accept the subcontractor's offer? Show your calculations. Well, at first, it may not make sense that $3 per unit at the in-house manufacturing, but someone else wants to do it for $9 per unit, and they're able to do up to 10,000 units. Now, should we consider this? Yes, because that's our bottleneck here. So anything that can add capacity, we at least want to take a look and run the numbers. Now, if it's not going to add to total output because it's not the bottleneck operation like we just talked about in the previous requirement, then we don't have to worry about that. We don't even consider that. But because this is the bottleneck operations within the company, we want to see if we can expand capacity, because if we expand capacity, we can increase annual production. So let's take a look here. What's our increase in annual throughput margin if we allow them to do 10,000 units? So what was my throughput margin? It was what? We calculated it was $40 per unit times how many units can they do? Well, they can do 10,000 units. So my additional increase in contribution or throughput margin is $400,000. Now, how much is that going to cost me for that additional capacity? Even though it's going to cost us $3 per unit, they're going to charge us $9 per unit. But let's see if that makes sense. How much is it going to cost for 10,000 units at $9 a unit? Well, that's going to be 10,000 times $9 is 90,000. So in this case, what's my increase or decrease in operating income? Well, I'm going to get additional throughput margin in terms of dollars at 400,000. And to get that 400,000, it's only going to cost me 90,000. So I actually have an increase in operating income under this scenario by 310,000. That's why we do not focus on fixed cost per unit, or we even focus on irrelevant costs. We want to look at each decision we're going to make, and see how does it increase or decrease operating income. Let's run the numbers, especially if it's in a bottleneck portion of the company. If this had been the machining company, we wouldn't have even wasted our time, because that's not the bottleneck. We need to add capacity to the bottleneck, which is the finishing department. So this is why we even considered to run the numbers, whereas we didn't in requirement 2, because requirement 2 had us adding capacity to a department that was not bottlenecking. Now let's take a look at requirement 4. The Hammond Company offers to machine 5,000 units at $3 per unit, half of the $6 per unit that it costs Denver to do the machining in-house. Should Denver accept Hammond's offer? Show your calculations. Now, even though this is not the constraining department, that's constraining or bottlenecking operations, the machining, the cost per unit is actually half of what we determined up here. And this is fixed operating cost per unit, $6. So should we even think about this in this situation? Well, it depends. We're not told that we're going to avoid these fixed operating costs per unit if we outsource this to make 5,000 units at $3 per unit. So what we're actually doing, if we're not going to avoid any of these costs, and fixed operating costs on total are not going to be avoided at all, then all we're doing in this situation is adding to costs. And how much cost are we adding in this situation? 5,000 units times $3 per unit. We're adding $15,000 to the cost. So if we actually did this and took Hammond Corporation up, we would actually be reducing operating income by $15,000. And that's because we're assuming that we are not avoiding any of these costs. And the reason we're assuming that is because we're not told specifically that we're avoiding any of these costs. If we're told that we're going to avoid certain costs, then we take that into consideration. And we look at this example or this requirement, and we look at this offer a little bit deeper. But if we're already going to incur those costs, and by outsourcing this 5,000 units, we're going to incur $3 per unit additional costs. Does raising our costs make sense in this situation? No, it doesn't. So why would we want to increase our costs and decrease our operating income by $15,000? And that's because we're not getting rid of these costs, any portion of these costs. Now, if we were getting rid of some of these fixed costs, by outsourcing some of these units, then it makes sense to at least look. But if we're not going to reduce any fixed costs and we're just going to incur additional costs, then that makes no sense either. So now let's take a look at requirement 5. And actually, if you notice, requirement 5 and requirement 6 are identical. And it looks like the publisher listed them twice, so we're just going to do it once. We're not going to do the same thing twice. So let's take a look at requirement 5. Denver produces 2,000 defective units at the machining operation. What is the cost to Denver of the defective items produced? Well, the cost of the defective items is going to be what? Well, if we make 2,000 units and our variable costs are $35 per unit, as we determined up there, it's going to cost us $70,000. And that's just in cost alone. Do we suffer any loss of output in this situation? No, because even if we have 2,000 defective units, we have the capacity to remake those 2,000 units because our limiting constraint is the finishing department. That's our bottleneck operation. So as long as I have additional capacity to make those units, then the only loss is going to be the cost actually poured into making the defective products. Had this been in the finishing department, then we might consider a loss of operating income or contribution margin as well. So, but since this is just, now we're going to lose operating income because we're throwing away $70,000. But we're not losing any annual output because this is not the bottleneck of operations. The finishing department is the bottleneck. We've mentioned that a few times here. The machining department has a lot more capacity, so if it makes 2,000 bad units, it can always just make up the, remake 2,000 units, and we're not going to have a problem. So, and let's take a look here. And actually, I just realized that 6 is not identical to 5, so let's go ahead and go to 6 here. Denver produces 2,000 defective units at the finishing operations. What is the cost to Denver of the defective items produced? Now here, we're not talking about just costs in the finishing department. We're talking about lost contribution margin as well. So we're losing everything. So what are we losing here? We're losing the cost to make those units plus the cost of contribution margin lost. Why? Because if we're making 100,000 units and that's all we can do, and 2,000 are bad, well, they've already been produced. Do we have the ability to go back and have the excess capacity to remake those 2,000 units? No, we do not. So in this case, I'm going to, by selling 2,000 units, I'm going to lose my $75 per unit that I'm going to sell. So I'm losing my contribution margin and my costs. So I'm going to lose $75 times 2,000. And so in this case, I'm losing $70,000 of variable costs, and I'm also losing $80,000 of contribution margin because that's what I'm sacrificing when when the problem happens in my bottlenecking department. So the cost of making bad units and defective units in the finishing department is critical, much more critical than the machining department. Why? Because the machining department has capacity to remake those units. The finishing department does not. It's maxed out. So if we can only make 100,000 units and 2,000 units are defective, we're only going to have 98,000 units that are good that we can sell to customers. So we're not only losing the cost of those 2,000 units, but we're going to forego and lose the contribution margin on those as well. So hopefully this exercise explains the concept of throughput or contribution margin. We use the term throughput margin here because there were no other variable costs, but we really could have used increase in contribution margin, which we might have more accurately used if there were direct labor or variable manufacturing overhead costs. We would have just included those. But hopefully you get a sense now of the decision-making process in dealing with constraints. between the last exercise and this exercise. Hopefully you get a better understanding of constraint, which products we should focus on as we did in the last exercise. And then in this one, which one should we focus, what is our bottleneck? What is constraining us from putting more out? What if the company had demand for 120,000 units? Well, then in this situation, what would happen? We would be losing out on contribution margin of 20,000 units. If we had demand for 120,000 units, we'd be losing contribution margin of 20,000 units. Why? Because we've lost sales because the finishing department can only have output of 100,000 units. So there are a number of things to look at with the bottlenecking and constraints. So this is Leroy Meadows. I want to thank you for joining me. Have a good day.